So as I told you before, all the physical interactions that we do in our daily lives, we use our touch sense. Let's think about picking a glass action that we do every day. It sounds very simple, right? We just grab a glass, and at the moment that we touch the glass, we can feel its material properties, its temperature, its shape, if it is like slippery or it is frictionless, or if it is hard or soft, right? It sounds very simple, but actually, if you look very closely, if you look at, for example, the fingers here, they deform largely, right? Their contact evolves during time, and this evolution is the one that we sensed actually. And if you look very closely, uh, this finger here, it's not that simple actually. Like it evolves during time in a complex manner so that we can feel these material properties of this glass. So if we kind of draw a general process of tactile sensation, we start with the skin object contact, and this skin object contact, it forms the skin, or it kind of changes the skin temperature so that it stimulates the receptors in our skin. These receptors are the sensors that we sense the tactile stimuli by our skin actually. And these receptors are connected to nerve fibers, which fires signals depending on the stimuli that we receive by our hand, by our skin. And uh, by collecting all these fires of different neurons, we have neural codes, which is sent to central nervous system, which is our brain, our spinal cord. And from the sensory cortex of our brain, we can sense the tactile stimulation that happened. So we can actually like sense if this glass, what are the proper material properties of this glass, if it is hard, if it is cold. We can all sense these things at the first second, but all in the first second, all these process is happening actually. So it's very complex. So what if we lose our tactile sense? I mean, today I talked a lot about tactile sense, tactile interfaces. Have you ever thought what happens if we lose this? So actually in 1988, they made a very good experiment in Umeå University by the Roland Johnson's lab. They asked participants to light a match, very simple task, right? And then they anesthetize their hand so that they cannot use their tactile sense, and they ask the same task again. They ask the subjects to do the same task again. So let's see what happens. So in the beginning, they do the task without any problems. They could hand the match, and like in 1 second they can light it. And now they anesthetize their skin, and now unfortunately they cannot even hold a match because they don't have tactile sense. They finally do it with their visual cues and also kinesthetic cues, but it's very hard to do a very this simple match lighting task. So I hope I could convince you about importance of our tactile sense. So I can explain you about our skin, which is the tactile sensation organ. Our skin has two main functions, which is protecting us and providing information about stimuli. It has two layers, epidermis, which is the outer layer, and dermis, which is the deep tissues. And it has two types, glabrous and hairy. Glabrous skins is our hand, lips, and fingertips, and the hairy skin are the rest of our body. And if we look at our skin very closely, there are different kind of receptors and nerve endings that can help us to perceive tactile stimulation. So thermal stimuli are sensed by thermoreceptors. pain stimuli are sensed by nociceptors, and mechanical stimuli are sensed by mechanoreceptors. So let's start with thermoreceptors. Thermoreceptors are free nerve endings, and their receptor fields are very localized, usually 1 to 4 millimeter, and they are sensitive to rate and magnitude of change. They have two different types, cold and warm receptors. Cold receptors are located in or just below the epidermis, and they have very poor spatial resolution. Warm receptors located in dermis, they also have poor spatial resolution, but there are more warm receptors than cold receptors. Nociceptors, the ones that feel the pain stimuli, are again free nerve endings, and they respond primarily tissue damaging stimuli. They also respond to extreme temperatures about 45 degree or below minus 15 degree. And sometimes they respond to strong mechanical stimuli so that they can warn us to when we are doing a task which is dangerous for our body, for example, they can warn us about this stimuli. And they are located in or just beneath epidermis, but their receptive field is around 25 millimeter square, so which is a kind of large receptive field. Mechanoreceptors. Mechanoreceptors transduce skin deformations such as vibration, pressure, shear, texture into neural signals. And we have about 500,000 mechanoreceptors in our skin, with about 20,000 in each hand. So mechanoreceptor density differed greatly between hairy skin and glabrous skin. So denser receptors means that increased tactile sensitivity. So from this information, we can say that stimulation location is an important design consideration for tactile interfaces. For example, if you would like to use the same wearable device that you use for your hands, maybe it's not possible to deliver that the same stimulus to the arms because we don't have that many mechanoreceptors, for example, here. And mechanoreceptors are classified into four based on their receptive fields and also nerve fibers that they are connected. So Meissner corpuscles and Merkel receptors have small receptive fields, and Pacinian corpuscles and Ruffini endings have large receptive fields. So if they have small receptive fields, they have a better spatial acuity. And for the adaptation speed, Meissner corpuscle and Pacinian corpuscle are fast adapting receptors, and Merkel receptor and Ruffini endings are slowly adapting receptors. What does this mean? Fast adapting receptors fire, the connected nerve fibers can fire when the stimulus starts and the end. So they only respond to transient stimuli. But slowly adapting receptors can fire nerves during the whole stimulation time. So they can, these nerve fibers can spike for the whole interaction. So based on this information, we can say that stimulation area and frequency are important design considerations for tactile interfaces. So depending on the tactile stimulation that you would like to deliver to the user, you need to make sure that they kind of respond to correct mechanoreceptor in a nice way. And also, if you look at very closely, Pacinian and Ruffini receptors are located in the deep tissues, whereas Meissner and Merkel receptors are located just below or in the dermis. And the Merkel receptors are most sensitive to low frequencies, such as between 2 to 32 hertz, and they are most sensitive to pressure and small-scale shape stimuli. Meissner receptors have larger frequency range to 8 to 64 hertz, and they can detect sleep and force changes. Ruffini receptors are sensitive to 0 to 8 hertz stimuli, and they are mostly sensitive to directional force and skin stretch. And pacinians are uh, detecting mostly acceleration and vibration sensation, and they are mostly sensitive to 64 to 800 hertz frequencies. However, when we touch something, let's say that a glass, all of our mechanoreceptors, all of our receptors actually in our skin work together. For example, here you see a grip example. So this person grips something you can think as a glass, for example. In the beginning, at the first touch, all the all the neural fibers which are connected to receptors, mechanoreceptors, are fired. But when there is not any change, the fast adapting receptors do not fire anything. Uh, but when there is a change in the force, in the transient, they fire again so that we can understand making and breaking contact between objects. From the slowly adapting receptors, we can understand contact timing, contact sites on digit, direction of contact force, friction information, and local shape at grab site, for example. So we can say that touch is a team effort, and we cannot uh, we cannot just say that these receptors are more important than the other ones. So all of them are working together to make us perceive different kind of touch stimulation. So that was it today. If you have any questions, I can take them now.